For this video, we're going to make a change to our high-low game. So open up high-low.py, and that's the one that we used in an earlier video. Now we can use an else clause with our while loop, and there's our while loop, to make the game a bit more impressive. Now let's have a look at what we're going to do. Alright, so in the binary search slides earlier, we worked through what happens when we try to guess the number 7. We were guessing in the range of 1 to 10. So I want to quickly review those earlier slides. We start off by guessing the midpoint between the low and high values. Our first guess is 5. We're told to guess higher. That means the answer must lie somewhere between 6 and 10. The new midpoint is 8, which becomes our second guess. We're told to guess lower. That means the answer must lie somewhere between 6 and 7. Our third guess will be 6. Where things get interesting is in the next slide. 7 is greater than 6, so we're told to guess higher. The low value becomes equal to the high value. When we went through this example earlier, I said at this point a human would guess 7 right away. I also said that the computer has to do the calculation first, but that's not completely true. Rather than use our formula to calculate the new midpoint, the computer could test to see if low is equal to high. If low does equal high, the computer then doesn't have to ask us if the guess is correct. When low and high are equal, it must have been the correct number. Note that this is only the case because all numbers are present. In a normal binary search, when what we're looking for may not be present, this doesn't apply. We can make our program a bit more impressive by not asking if the value is correct. We know it must be when low is equal to high, and we can tell the player that we've guessed their number. And the changes to our code are quite simple, so let's swing over and get started with that. Right, so on line 23, we break out of the loop when the player confirms that we've guessed the right number. In the cases where we know we've got the right number, we can cause the loop to terminate and use an else clause to tell the player what their number was. So we're going to start by changing the condition for the while loop. Let's go up and do that. So instead of while true, we're going to put while low is not equal to high. So we continue looping as long as low doesn't equal high. When they are equal, the loop will terminate. And if that happens, and it won't happen for all numbers, just some of them, but when that happens, we know that we've found the correct number. So let's add the code for that. So it's going to be else down here on line 29, else, colon, line 30, print, parentheses, double quotes, you thought of the number, left to right curly braces, double quote, dot, format, low in parentheses, and the right parentheses to end the line. And on the next line, print, I got it in, and left to right curly braces again, guesses, double quotes, dot, format, guesses, and 2 right parentheses. Now just before I run the program, I'm going to comment out up here the diagnostic information that we're printing on line 9. So let's do that. Alright, so let's now run the program. So my number's going to be 100. Press enter to start. So with that number being 100, the first guess is obviously too high, so we're going to put lower, 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 higher, higher, lower, lower, higher. Now as you can see, the last guess there is 99. If we tell the computer to go higher, it doesn't have to ask us if 100 is correct, because you can see it's already guessed 101, and now it's guessing 99. So if I press H here, which is correct, because it's higher than 99, you thought of the number 100, I got it in 10 guesses. So at that point, when I selected that, low and high both equaled 100, and the while loop terminated, and it terminated normally, and the else clause was invoked, and we got the output on the screen as you can see. So that's a bit more impressive. What would be really good is if we could get the computer to do that for any guess, but we can't. It only knows it has the correct answer when high and low converge to the same value. With a high value that's close to an exact power of 2, that happens about half the time. 1000 is closer to 1024, and the computer can tell it has the correct answer for 489 numbers that we think of. Now, if you'd like to run this code in the debugger to help understand what's happening, you'll find it a bit frustrating. It can be annoying debugging code that waits for input. Setting breakpoints can help a bit, but there's another technique you can use, and I'll show you what that is in the next video.